equals x to the fourth times e to the negative 9x.
Excellent. So we want to find the critical numbers.
Yes.
Okay, I will add something else because we are talking. You don't have to enter those, of course. But I would like to also determine if they are max-min.
Okay.
I don't want to just stop at this. But
Sure.
you will enter whatever you need to enter in WebAssign.
Okay.
Good. So we know that critical numbers come from two possible sources, right? Either from f prime being 0 or from f prime being undefined, but at a point where the function is defined. If both the function and the derivative are not defined, that cannot be a critical number.
Okay.
Okay. So we know that this function is always defined because basically this is x to the fourth over e to 9x, right? So in the exponential function, I can plug in anything. So the domain of this function is all real numbers. This could never be 0. E to 9x can never be 0. Remember, the graph of e to the x or e to 9x or e to whatever you want x is this, which means the domain is all real numbers and it's never 0. So this is important to establish from the very beginning. Because eventually, if I determine, it's not going to be the case, but eventually, if I determine that f prime is undefined at a particular point, since the function is defined everywhere, then I will say that is a critical number. So that's why it's very important to establish the domain of the function. Now I will move on to what I need to look at. So f prime of x. Will anyone be interested to help here? Anyone?
4x
to the third.
To the third.
Yes.
Times e to the negative 9x.
Yes.
Plus
x to the fourth. Yes.
X to the fourth times e to the negative 9x times negative 9.
That's it. So of course, remember the key factor. I'm going to write it as many times as you want me to. Factor and simplify are always in the back of our minds at all points in time. So obviously, I'm going to factor out x to the third. I'm going to factor out e to negative 9x. And now let's see what is left. So what is left from the first term? If you don't do this, you're going to make, I'm not talking to Sean, I'm talking to everyone. If we don't do this, then we're going to have more work to do and it will be more difficult.
4?
Yes, a 4. Also, I have a 9 here, right? So this is minus 9x.
9x?
Yes, because I have an x cubed and I have x to the fourth here. So when x is left, this is out, and I have 9x. Is this okay?
Yes.
Okay, so now when I set this equal to 0, this can never be 0. Don't even look at it. But x could be 0. Or this could be 0, which makes it 4 over 9. When x is 0, when I set 4 minus 9x equal to 0, I move whichever term you want. 4 equals 9x. I divide by 9 and I get this. So this is a critical number and this is a critical number. Now, so that's your answer. That's it. But I also want to determine whether these turn into max-min or not. For max-min, I do not need the second derivative. Unless you want to use the second derivative test. That's fine. You can. Okay. So we have 0 here and 0 here. When I plug in the function 0 and I plug in the function 4/9, I should get the y values. But when I plug in 0 is 0 times 1, which is 0, so this is easy. Now when I plug in 4/9, I will do it with the calculator to see what I get. I'm going to share my screen and go to the calculator and put in the function x to the fourth. Why this is important is because that's what we are working on. and we need this. And that power is negative 9x. Okay, so all I want to plug in is 4/9. So, gee whiz, look how tiny this is. No, I'm sorry. How tiny this is. 7.14 times 10 to negative 4. So 1, 2, 3, 7, 1. Okay. Good. So I want to study the sign of the derivative. So when I plug in negative 10, this is negative, but this is positive. So this will be 94. So this is positive, this is negative, this is always positive. I don't even want to look at it. It's a waste of time. So negative and positive. Now 4/9 is, so what would I want to plug in? Like 0.1, positive and positive, right? With 0.1, this is 0.9. 4 minus 0.9 is a positive number, and this is positive. Okay, last one with 10. Positive but negative. Negative 90 plus 4. So now in addition to what I was asked to determine, I also know that this must be a local min, 0, 0, 0, 0, and 4/9, this tiny number, must be a local max. How do I know? Because the function here is increasing and here is decreasing. Here's decreasing and here's increasing. Very good question. How is this? Is that okay?
Yes.
Other questions for me? Anyone? Anyone? Okay, so in that case, I'll share my book. I need a sip of water. Sorry about that. I'll share my screen, and where is the book? The book is, where is my book? Right here. Okay, can we consider number 1, 4.1 done, completed? Can we forget about it? Do we need anything else from 4.1? Anyone? Okay, well, you'll stop me if you find anything else from 4.1. Let's continue with 4.3, which we did not complete. Okay, we need more examples. And let's take a look. Yeah, let's take a look at one of these problems with a graph, for example. So here we're asked to find the open intervals on which it's increasing, decreasing, concave up, concave downward, and points of inflection. So if you carefully look at the function, you will see that the function is opening up, 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 up till this point, right? So it's concave up between 0 and 2. Then it's concave down all the way. No more inflection points. So concave up and concave down. So for concave up, for part C, I would write between 0 and 2. And for part D, I would write between 2 and, what is this, 2, 4, 6. Coordinates of points of inflection or inflection points, there is only one right here, when it changes from opening up to opening down, right here. So this is the point 2, 3. Then increasing, decreasing. Okay, here it is. Decreasing, decreasing. So between 0 and 1 and 3 and 4. Decreasing between x equals 0 and x equals 1, and decreasing between x equals 3 and x equals 4. The rest is increasing from x equals 1 to x equals 3, union from x equals 4 to x equals 6. Okay.
Can you explain the concave? Because I'm not following how from, I guess it is 0.3 onwards, it's concaving downwards.
Okay. So in between this interval, between this point on the graph and this point on the graph, can the graph hold water?
No.
No. Can the graph between this point and this point hold water?
No.
Can the graph between this point and this point hold water?
Yes.
That's it.
Okay, so it has to be a smooth, like, curve. It can't have that.
It has to hold water.
Okay.
If it holds water, it's concave upward. If it cannot hold water, it's concave downward.
Okay.
Better?
Yeah.
Perfect. Very good question. Anyone else? Other questions, please? Okay. So we looked at a problem like this, finding the increasing, decreasing, local max, local min. I don't want to do piece by piece. We know now everything, so we can put everything together. Increasing, decreasing, inflection points, concavity, everything. So we also looked at an example like this. This was 24 that we worked on. So we can choose another. All these are just, and also this is an important type of problem that puts everything together, including the table and how to work with the table. So we have to choose a problem from 36 through 41. I let you choose anything that works for you. So that's one set. And they're all the same thing, max, min, intervals of concavity, the same thing. And we can choose another from here. They are all the same. They're asking us the same thing over and over for different functions. Okay, so I'm ready. If you want me to choose, I will choose, or if you want to choose, let's do it. So let's start with these. We've had this before in other chapters when we put everything together and present a potential graph. Which one?
Can we do 40?
Yes, so let's do 40. It will take me a minute to copy all this, but it's important. So f prime of 0, because I have to stop sharing. F prime of 0 and f prime of 4 are 0. F prime of x equals 1 for x less than -1. F prime of x is greater than 0 for x between 0 and 2. F prime of x is less than 0 for -1 to 0. Union 2 to 4. Union 4 to infinity. X greater than 4. Okay, now limit of f prime of x as x approaches 2 from the left is infinity. Limit f prime of x as x approaches 2 from the right is negative infinity. The second derivative greater than 0 for -1 less than x less than 2 union x less than 2 greater than 2 less than 4. Second derivative less than 0 for x greater than 4. Okay, I think I copied down everything, but let me double check. F prime of 0, f prime of 4 are 0. F prime of x is 1 for x less than -1. F prime of x is positive between 0 and 2. Is negative between -1 and 0. Union 2 and 4, correct. Union 4 to infinity. Okay. F prime of x is infinity, f prime of x, so left and right of 2. F double prime, second derivative is greater than 0 between -1 and 2, union 2 and 4, And the second derivative less than 0 for x greater than 4. Okay. So this is basically more an exercise in how to organize the information and graph. That's the most important part.